Hi, so in this video, I'm coming to solve this calculus problem, and the problem reads, show that the differential of 0.4x raised to power 5 brackets 0.2 minus ln 5x bracket closed must be equals to kx raised to power 4 ln 5x. So where k is an integer to be found. So the second part of the question reads, we are required to simply express ln 125 x raised to the power 3 in terms of ln 5x. And the last part of the question says, hence, find the integral of x raised to the power 4 ln 125 x raised to the power 3 dx. And this question is a past question for Cambridge, like a Cambridge exam. So I believe for students who are in the level for Cambridge exam, will be able to stand a better chance to be able to try to understand this problem and put it into practice. Possibly by the end of the solution, I might give something similar to that for them to try. Or the subsequent videos, I will try to make again 2 or 3 videos relating to similar problems like this. So we are required to show that this differential must be equals to kx raised to the power 4 ln 5x. But here we have to take note of one point. If we are given the differential of this, let's say x raised to the power 4, another form to rewrite this differential of x to the power 4 can be written as y equals to x raised to the power 4. It simply means in this form, it implies we are going to differentiate this function. Here again, the same thing, we can rewrite this value as y equals to x to the power 4. It also implies this is the function, this as well is the function. So moving from the function, going to the next function, this is the derivative. And moving from this first derivative, moving to another point, this is the second derivative. And so on to the third derivative. So you see, so the purpose of derivative is simply means the purpose of finding the derivative is simply means when you differentiate the function given. So we have to take note of this. So if we rewrite this, we are given the differential of this equals to this. So we are required to play with this to give us something which must look like this. So we take this relation given can be written as y equals 0.4 x raised to power 5 into 0.2 minus ln 5x. So this is it. So we are required to play with, so this derivative, this differential function can be written as this. So we are required to play with this to give us something like this. So this is the format. So if we use this, if we look at this, this is the product function. Because we have a function here, 0.4 x raised to the power 5. This is a term which multiply by this bracket, and the bracket again, we also have another 2 terms. So we can use any method to differentiate this function. The end of the day, the results we have must give us something like this. But in this case, we have a ln here. How can we differentiate a ln function? For example, if we have ln 3x, let's say y equals to ln 3x. So if we differentiate y with respect to x, it's going to be dy dx. So anytime you differentiate a ln function, differentiate the function given. So when you differentiate 3x is 3, and you rewrite what you have there, so this is 3x. So the end of the 3 cancel 3, so you have 1 all over x. So the derivative of ln 3x is 1 over x. The same thing, if we have y equals to log 6x, is the same thing. So the derivative of log 6x, differentiate 6x, which is 6, and you rewrite the value. So the end of the 6 cancels is going to be 1 upon x. So anytime you differentiate a logarithmic function or a ln function, differentiate the function, the result you are going to have, divide it by the original function given. Let's have something which might also look similar. Y equals to log x4 plus 3x cubed plus 2x squared plus 4x plus 3. We are required to differentiate this logarithmic function. The same thing, when you differentiate y with respect to x, we have dy dx. Differentiate this whole function. When you differentiate x4, you are going to have 4x raised by 3. When you differentiate 3x cubed, 3 times, it's going to be 9x raised by 2. If you differentiate 2x squared, it's going to be 4x. If you differentiate 4x is 4, plus if you differentiate 3 is 0. If you write the whole function, x4 plus 3x cubed plus 2x squared plus 4x plus 3. This is how it differentiates logarithmic function. So I hope this point is clear. So if this is clear, we consider the problem given. We have y equals 0.4x raised to the power 5 multiplied by the bracket 0.2 minus ln 5x. So I know you know how to differentiate ln 5x, because the differential of ln 5x, just differentiate 5x, which is 5, divided by the function given, which is over 5x. I see. And always, when you differentiate a constant, it's always 0. The differential of a constant, what we mean by a constant is any variable or a number with a degree of 0. Like x raised to the power 0 is a constant. So when you differentiate x raised to the power 0, you have 1. If you differentiate 2, when you differentiate x to the power 0, because x to the power 0 is 1, when you differentiate x to the power 0, the answer is 0. When you differentiate 2, the answer is 0. When you differentiate 10, the answer is 0. When you differentiate 100, the answer is 0. You see, so when the differential of any constant is 0, and a constant simply means when the degree is 0. So if we differentiate this term and also differentiate the terms inside this bracket, when we are going to differentiate this 0.2 is a constant, definitely we have 0. When you differentiate this, like I told you, we are going to have 5 divided by 5x. So we have to take note of this. So if we differentiate this function, instantly, the differential of y with respect to x, this will be dy all over dx. Now we have two terms. It remains with you. You have to keep one term at a constant. It depends which term you want to keep constant. Let's say we keep this bracket constant. If we keep this bracket constant, 0.2 minus ln 5x, times, we differentiate this. If we differentiate this, always, when you differentiate a power, let's say we are differentiating x raised to the power n. The differential of y with respect to x is going to be dy all over dx. Always the differential, the powers or the degrees of that variable decrease by 1. And the result, you multiply that power to the coefficient of the term given, which implies we multiply this to this coefficient, which is nx, and you reduce it by 1. This is how you differentiate a value. Similarly, if you have y equals to x over 10, you multiply it, which is 10x, and you reduce it by 1, which is this. So the final result for this is going to be 10x raised to the power 9. So the differential of y equals to x raised to the power 10 will give us 10x raised to the power 9. So this is the format. So if we differentiate, if we keep this constant, we differentiate this. 0.4 is just a coefficient of this x. So we multiply 5 times, it's going to be 5 times 0.4 x over, you reduce 1 from this 5, which is 4, plus, so we kept this constant, we differentiate this. Now we are going to keep this constant and we differentiate the bracket. So if we keep this value constant, which is 0.4 x over 5, if we differentiate what is inside the bracket, this is a constant. When the 0.2 differentiate, you have 0 minus, we differentiate in 5x, as I said. Differentiate 5x, which is 5, and you maintain the original value, which is all over 5x. So we are done, you see. So calculus ends here. What follows now is just basic algebra. So how best you can be able to play with your numbers or your figures. So we rewrite dy all over dx. So we have 0.2 minus ln 5x times 5 times 0.4 going to give us 2x over 4 plus, we maintain 0.4 x raised to the power 5. 0 minus any number is just 0, so you're going to be minus. 5 cancel 5, going to be 1 upon x. So this is it. So this, we expand 2x raised to the power 4 times 0.2, going to give us 0.4 x to the power 4. We write our minus. 2x to the power 4 times this is going to give us 2x to the power 4 ln 5x plus Yeah, there's a minus sign here, so minus times plus, this is going to be minus. So plus times minus is going to be minus. So this x is the division. X, one of this x will cancel one of here. It's going to be 0.4 x instead of 5, because 5 minus 1 x is going to be 4. There's it. But if you look at it, so we write dy all over dx. This term, if you look at it, the same as this term, you will cancel. So definitely the value will be minus 2x raised to the power 4 ln 5x. So this is the first part. We are required to show that this value is going to give us this. You see? So if you compare this and this, they are almost the same. You see? So this is the same as, so this value is the same as kx raised to the power 4 ln 5x. So this and this is the same. So if you compare it, but we are told that where k is an integer, it can be 2, 3, 4, negative, any number. So if you compare x to the power 4, x to the power 4, ln 5x, ln 5x, so therefore the value of k will be minus 2. So this shows that k value here is minus 2. So the value of k is minus 2. So this is the end of the first part of the problem. We have that. So if we move to the second part of the question, we are required to express ln 125 x to the power 3 in terms of ln 5x. If you compare, here is 125, here is only 5. But we have x cubed, here is x. Simply means we simplify this to give us something in this form. So if we do that, we say Roman 2. So we are given ln 125x raised to the power 3. You see that? So, but we quite aware that 125 is the same as 5 by 5 by 5, which is the same as 5 raised to the power 3. You see, so 125 can be written as 5 raised to the power 3 and write this x raised to the power 3. So 125 can be simplified as this way. You see, but this again can as well be written as, when the 3 moves, you have 3 ln 5x. So you see, it can be written in this form, but you can also rewrite it as, so you see, ln 125 x to the power 3. This is 3 times, can be ln 5x for one time plus ln 5x for the second time plus ln 5x for the third time. So this 3 ln here can be expressed in this form as ln 5x plus ln 5x plus ln 5x. So this is the end for the second part. So if we move swiftly to the third part says, hence, find the integral of x raised to the power 4 ln of 125 x raised to the power 3 dx. So we are required to find this value. But before we move to this point, we have to aware that, let's rewrite this function, d all over dx into 0.4 x raised to the power 5 into 0.2 minus ln 5x. This is equals to, this value equals to this, but this we have it to be this, which is negative 2x raised to the power 4 ln 5x. So we have to take note of this point. This point should be mastered, because we are required to show that this equals to this. But what is k? K is minus 2. When you slot minus 2, it gives us that expression. So the left-hand side term equals to the right-hand side term. So having this, we are required to evaluate this integral of x to the power 4 ln 125 x to the power 3 dx. So if we move forward, we consider the integral of x raised to the power 4 ln 125 x raised to the power 3 all dx. But this can be written as x raised to the power 4, but what is this value? Ln 125 x to the power 3. Ln 125 x to the power 3 is this, which is 3 ln 5x. We simplify it. I say, because the integral of ln 1, the value of ln 125 x cubed, when simplified, it is 3 ln 5x. So instead of writing this, we rewrite as 3 ln 5x. So which can as well be written as 3, the integral of x to the power 4 ln 5x. This is it. So this integral of x4 ln 125 x to the power 3 dx is equals to this. You see, we take our time and to have the original expression. So if we move forward, what else again are we going to do? We'll try to compare. But if you look at this expression, here we have x to the power 4 ln 5x, x to the power 4 ln, because this is the derivative. Because like you can move from derivative to a simply the integral form, and you can as well move from the integral form to the derivative form. What I'm trying to say here is, let's just say if you have y equals to x raised to power 7, right? This is the function. If we differentiate this, dy all over dx, this is going to give us 7x to the power 6. So this is the derivative. We have moved from function to the derivative. If we want to move from here to here, we call it to be derivative. And when you move from derivative to function, it's what we call integration or anti-differentiation. That from function to derivative, we call it to be differentiation. While from differentiation or from derivative to backward to function, we call it to be anti-differentiation, or which most people call integration. So from y to dy dx is derivative, and from dy dx going backward to function is integration. So if we want to have this value again, we cross multiply. Since we have dy all over dx equals to 7x to the power 6, we can cross multiply. So dy equals to 7x to the power 6 dx. You integrate both sides, So when you integrate dy is y, you see, and when you integrate this, is going to be integration. Like the word integration, we always add the powers of the variables given. You see, so the variable here is x, and you have to add 1 to the index. So when you add 1 to this, it's going to be 6 plus 1. You must add a constant, because the reason why we add a constant, the integral here does not have any limit. The limit herein we have AB. So the limits are given, no need for you to add a constant. So when the limits are not given, you must add a constant. So therefore, this can as well be given as 7x over 7. You see? But you have to divide it by the power given, which is 7. So 7 cancels 7. So therefore, you have x over 7 plus a constant c. So this is how we integrate. So you can move from function to derivative, which is differentiation, and you can move from derivative backward to the function, which is anti-differentiation. Or sometimes you can move from the second function to the first function, is simply by anti-differentiation, and you can move from second function to the third function, which is differentiation. So these are some of the logic we have to take note of. So taking note of that, if we continue here, so we have here, if you look at this, x to the power 4 ln 5x, you can see it's x to the power 4 ln 5x. So we need the differential of this. So when you return here, from here to here, it's simply integration. So we need to find the value of this. Simply we divide both sides by minus 2 here. So let's have this. So therefore, let's take note of, say note, we have this value. If we divide minus 2, you're going to be minus half the derivative of d all over dx into 0.4 x over 5 into 0.2 minus ln 5x equals to, when you divide minus 2, it's cancelled, it remains x4 ln 5x. So this is what we have. You see, x4 ln 5x equals to x to the power 4 ln 5x. This is it. So therefore, but x over 4 ln 5x is what is given here. So definitely this integral, when we move backward, is going to be the integral of this. So therefore, the integral of this value, x to the power 4 ln 125 x to the power 3 dx equals to negative half times the differential of this. You see, and the minus after the differential of this, and the differential of this is going to give us this, and simply the integration of this will give us this. So this value, which is this here, we're going to give us this, which is 0.4, but let's forget we have 3 here, times the integral of this whole value is this, times 0.4 x to the power 5 into 0.2 minus ln 5x. Since we are integrating, we're going to give you a constant c. So therefore, this can as well be simplified with negative half or can say multiplied 3 times negative. I go to negative 3 upon 2 ln, no, not ln, not ln. So we have negative 3 upon 2, 0.4, we write this x raised to power 5 into 0.2 minus ln 5x plus c. This is the differential. Yeah, this is the final point of this. Thank you and stay blessed.